All right, Austin, this is the question that you sent me. The question was a 25,000 volt three-phase three-wire system feeds a delta-delta transformer with a rating of 100 kVA. So this three-phase transformer is rated for 100 kVA, and it is used to supply a 600 volt balanced three-phase load of 80 kilowatts at a power factor of 0.6. What they want us to find is the primary line current. And the first thing you should do for questions like this is do a drawing. Do a little drawing of what this transformer connection looks like. It's pretty straightforward. It's pretty straightforward. A delta-delta connection. It's fed on the primary at a certain voltage. It supplies a load at a certain voltage. And I always draw the load like this because they don't tell us whether the load is Y or delta connected. So I just draw it as a circle. And it's 80 kilowatts at 0.6 power factor. Now to find currents in a load like this, there are a couple ways you can do it, but I think I try to, as much as possible, practice using my three-phase power formulas. It's probably the best way to practice doing one like this. And the basic three-phase power formula is for VA. Three-phase VA total equals V line times I line times root 3. So that's the easiest formula to remember for power formulas. This load is in kilowatts, and that formula for watts total is just V line times I line times root 3 times cosine theta. So I could use that formula, but it's pretty easy to change this load into kVA as well. If it's a balanced load of 80 kilowatts at a power factor of 0.6, I can just draw a simple power triangle here. 80 kilowatts goes on the bottom side of it. Bars goes on the vertical side of it. Volt amps, of course, goes on the horizontal of it. Our power factor is 0.6. And the way to find the total VA is, if I knew the total VA and the power factor, I can always multiply the VA by the power factor to get the watts. So when we know the watts and we're trying to find the VA, we just do the opposite. So I'm going to take 80 kilowatts divided by 0.6. I should get a bigger number. And we get 133.33. So 133.3 kVA. So that's the apparent power of the load. And now we're asked for a current on the primary of this transformer. The load on the secondary is 133.3 kVA. And our rule we know for transformers is primary VA equals secondary VA. So if our load on the secondary is 133.3 kVA, then if I want to find a current on the primary, I can just say the primary VA is the same as the secondary. Any load on our secondary is always reflected back onto the primary, and we can think of that load as being connected right to the primary. So I have a 133.3 kVA load. This 25 kilovolts is the line voltage on the primary. So our formula here is pretty easy to use now. We're just going to solve for this, and we just have to rearrange this formula to solve for that. Hopefully you don't find these formulas too hard to rearrange. They're fairly straightforward. To find the line current, it's multiplied by V line and root 3. So I'd want to divide each side by V line times root 3 to get rid of V line and root 3 on this side. We're going to divide it. And whatever we do to one side of an equal sign, we have to do to the other side. So my I line is just going to equal the three-phase VA divided by V line times root 3. So 133.3 kVA divided by 25 kilovolts times root 3 should give me a line current of 3.08 amps. That looks like that's what the line current would be. Yeah, that looks right. And so that is the primary line current. That's the value we were looking for in this question. And so using our three-phase power formula, it's fairly straightforward. If they had asked us for a current on the secondary, the line current on the secondary, let's say, I could have used the same formula. It would have just been the same VA again, 133.3 kVA, divided by 600 volts times root 3, would have given me the secondary line current. If they wanted to know the phase current on our delta secondary, we figure out the line current, just divide it by root 3 to get the phase current. So for any of my currents, once I know what my load is and I do this little drawing, it's a pretty simple matter of if I can convert the load to VA using our simplest three-phase power formula to calculate the current that we want. Hopefully that helps out.